Well, good evening. I guess it's still good afternoon. We're going to go for section 3.4. And this is about measures and positions and how to calculate outliers. All right, so once again, start off with sharing. Yep. All right. We actually did this last video, and I said, guys, that's actually a formula. And what is a z-score? It's the difference in the data with the mean and divided by the standard deviation. Now, this gives it to you in two different ways. And I'm going to tell you, I don't memorize it this way. And I tell students of another way, a little bit different. All right, let me insert a formula. The z equals x minus the mean over the standard deviation. That's how I state it, period. Because it doesn't matter if you're talking a population mean or sample, population z-score versus a sample z-score, it's always going to be the x value minus which mean you have. And if you have a sample mean, means you really should have a sample standard deviation. So I just kind of cut it to the chase with this formula. All right. But it is actually two different formulas. One is for the population, one is for the sample, but it still translates to this. All right. Well, what does that mean? It's basically we're calculating the distance from the mean. Because you don't always have a full deviation like the empirical rule. The empirical rule works off exactly one deviation, exactly two, exactly three. What if you're at like 1.5 deviations? Well, this is how we calculate it. A z-score is those partial deviations. That's what a z-score is. It's a standard deviation. All right. So, oh, come on. So, we have a mean upper arm length of males at 38.6 with a standard deviation of 2.9. And we have the same for female. And it says who has the relatively longer arm length? Well, by pure number, it looks like the male does. So let's look at this male mean and all this. So the male was 41.1. And they told us that the mean for the male was 38.6 and has a standard deviation of 2.9. So bring out the handy dandy calculator on the computer. I really wish, oh, you know what I forgot to do? I didn't hit screen share and you're all probably sitting there screaming at me. No, I am. Yeah, I have been. I just looked at the wrong thing. All right. So handy dandy calculator time. I want 41.1 minus 38.6. I hit the equals, divide by 2.9. And my calculator is 0.8620689. So I'm going to round it to the 3. So it's 0.862. So I am 0.862 deviations. I'm not a full deviation away from the mean. A positive standard deviation means I'm above the mean. A negative deviation means I'm below the mean. So let's look at the female. And I'm cheating again. So the X value they want me to compare for the female is the 38.4. And her mean length is 35.8. With the standard deviation of 2.8. So calculator time. I have 38.4 minus 35.8. I get 2.6 divided by 2.8. And guess what? So relative size means comparison to the average. So even though the upper arm length of the female is shorter than the male's, but in comparison to the average overall, this female's above average because she is 0.92 further away from the mean. She's got a bigger deviation. She's further away from the mean. So the female has the bigger length. Now, many of us have heard, especially if you went through school and such, you ranked when you did these standardized tests, you was in the top 20th percentile. Well, it means you've got 80% people less than you. Percentiles are nothing more than percentages. If you tell me the 80th percentile, that's 80%. 98th percentile means you're in the top 2%. Percentiles are percentages. Don't let them get you confused. All right. So looking at percentiles. Typically, we talk about quartiles, which is nothing more than the 25th percentile. Q1, Q2, and Q3. Well, I'm going to tell you something. The Q2 is the median. Q1 is the first quarter. Q3 is the third quarter. And the fourth quarter, that's 100%. So basically what we're going to do is we're going to take our data and we're going to divide it into quarters. And I've got my little male dog again. The hi Gizmo. Hi everybody. You haven't noticed before, I said before, he's 15. He can't jump on the couch now, so he likes to decide to get on the couch when I'm videoing. So anyway, sorry about that. So we take our data and think of how we found the median a couple sections back. We divided the data in half. Well, we're going to find quartiles, the first quartile and the third quartile, the same way. This is stating it. First thing you got to put the numbers in order. All right. So we're going to take these numbers and put them in order. So I see 5, 18, not quarter. I see it 23, at 23, at 26, 36, 43. Now double check. 5, 18, 23, 23, 26. Yep, okay, I've got it. Now, if I find the median, remember, I count how many pieces it is. There's 7, divide by 2, and then round up. So right there, 23 is my median. Right? Now, basically what I'm going to do is I'm now going to take the median of the left half and the median of the right half. This is what this is basically stating. The first quartile is the median of the bottom half, and the third quartile is the median of the top half. So, what's the bottom half? Right there is the bottom half. And this is the top half. So the first quartile would be what? 18. So Q1, first quartile, is 18. Q2, or the median, is 23. And Q3 would be 36. Everybody seen how I did that? It's the middle number. It's a small data set, should be easy. I got 3 digits. What's the middle digit between the 3? All right. So there's my quartiles. However, how do we do it in StatCrunch? Well, we don't want to do this by hand if we have a bigger data set, correct? And I'll be honest, I added another data set. I get bored using the same old data sets, and I found one for the George Lucas characters. So we're going to use the George Lucas data set going forward. So let's find the 3 quartiles in the data set. So if you go to modules, remember how we find modules? Scroll down to the data sets, and since I just added it, it'll be the bottom one. You open it. When you open it, yes, I've already got it opened. There it is. And there are 26 characters. I click on the first box, Control A selects them all, Control C copies them. I now head back to StatCrunch. So I'll open StatCrunch. My lab, open it, scroll down to StatCrunch, from website, open stat, I click on var1, and I do a Control V. Now, we cannot do quartiles on qualitative. We can only do it on quantitative, which means the height. So how do we do it? So we can do stat, summary stats, columns. Try to go on this route yet? Click the height. Now, looky here. We have Q1. Again, if you're using like a Windows laptop, Control, clicks medium. And then I'm going to scroll back down. Q3. Compute. There we go. How we feeling on that? So Q1 is 168 centimeters. The median is 176.5, and Q3 is 185. So I'm going to take that back. So Q1 was 168. The median, or Q2, was 176.5. And Q3 was 185. Now we're going to need those numbers, okay? Because we've already discussed range. Now we're going to discuss the interquartile range. It means the middle 50% of the data. And the middle 50% of the data would be from Q1 to Q3. And we're going to need the IQR for finding outliers. So using this data, we're going to take, using this formula, and we're going to fill it in. Q3 was what? 185. Q1 was 168. I'm subtracting. That's it. I'd subtract Q3 from Q1. So I need my handy dandy calculator to tell me it's 17, I do believe. So 185 minus 168. There you go. I always double check. All right. I don't know why this is so small. There we go. Oh, I know why. They picked up the formatting from above. So yeah, IQR is the middle range. It's the middle 50% when we're using quartiles. All right. So that's one thing down. Now, why is it that I need? When we talk about measures of central tendency, we've already talked about mean and standard deviation. Well, we use that when the data is symmetrical. When it is not symmetrical, the median is what we use, and the median goes with the IQR. Never will you use an IQR with the mean, because stop and think about it. Standard deviation uses the mean to calculate it. And an IQR includes the median, which is in between it. So these guys go hand in hand, and this is all called the measure of central tendency. At this point, please pause the video and make sure you put some type of note down, because I promise you in a future major test, hint, hint, that some type of questions along the measure of central tendency will be asked. All right? It will be asked. So, let's see if I can't move this up, because as I start typing, things jump. So, why is the importance of an IQR? Well, the IQR is how we decide if we have an outlier. And this is what we use. We use lower and upper fences. Now, please do not get the lower fence and the upper fence confused with Q1 and Q3. A lower fence uses Q1, but then we go down below. We go lower than Q1 to check for outliers. An upper fence uses Q3, but we go above it to check for outliers above. You can have an outlier, which is your data that is odd. It doesn't fit with the normal pattern. Usually when we calculate incomes, if we're talking about the average income, we don't use the mean, we use the median, because the median, remember, isn't swayed by outliers. It's not swayed by it. So it's the reason. If you have a normal population, and let's say you have 300 people, but one of the 300 people makes $200,000 while everybody else is making around 30. Well, if I use the mean, it really make it look like people are making more than they are. So we use the median for things like average household income. It's not a mean, it's a median if they're doing it properly. If they're not, then they're using the mean to try to make it look like everybody's making more. Household house prices, median house price. Not, they'll tell you average. Well, remember again, when I said averages, it could be a mean, it could be a median. So things I've said previously are now coming into play. So how do we check? We use these two formulas. Where does the 1.5 come from? It's part of the formula. I get asked, well, why? It's part of the formula. It was calculated and created long before me. All right. So using the data, check for outliers. So our lower fence, remember, is Q1 minus 1.5 times the IQR. While the upper fence equals Q3 plus 1.5 times the IQR. So how do I calculate that? Well, first I got to get the quartiles. And I do believe I have those quartiles right there. So I'm going to bring them down just so we don't keep scrolling up and down. Sometimes it just makes life easier if you just go ahead and bring it down with you. So, all right, so Q1 was what? 168 minus 1.5 times the IQR. Well, we got to calculate the IQR, don't we? So up here, IQR equals what? The largest minus the smallest, which was 17. We calculated that already. So my upper fence is what? Q3 plus 1.5 times the IQR of 17. Now, off to handy dandy calculator. I know my cell phone doesn't like to do this improper. All right, so I got 168 minus 1.5 times 17. And I see 142.5. Not 172, I said 142. I'm going to do the same thing here now for the upper fence. I got 185 plus 1.5 times 17. And I get 210.5. So now I need to go look at my data. So I'm going to trot back to my spreadsheet. Right now, let's go to, Remember how we could sort? We put it here, that little arrow drops, and I want to sort by ascending. So I'm looking to see if there's any numbers smaller than 142.5. Because if it's smaller, it's considered an outlier. So I see 1, 2, 3, 4. So these are numbers below the lower fence. I got 4 outliers down there. They're smaller than the 142.5. So let's look at stuff bigger than the upper fence, which is 210.5. All right, 210 is, I've got 2 of them. I get 213 and 390. So all in all, out of this George Lucas data set of 26, I've got 6 outliers. It means they're so small. And I mean, let's face it, Yoda was a little tiny thing. And the little Jawas, and the little teddy bear type things, they were short too. And it doesn't surprise me R2D2 made the list. And it doesn't surprise me Watto. Kind of, well, maybe. I thought he'd be tall enough, but I guess he just misses the mark. And Jabba the Hutt, heck yeah, he was a big old blob, wasn't he? 390 centimeters in height. He's way bigger than the average. So these are all outliers. These are outside the normal range of stuff, so to speak. All right. So we've got 6 outliers. For below the lower fence and 2 above the upper. Boy, I can't type. So what are they? 66, 91, 107, 137, 213, and 390. All of these are outliers. Okay? Well, ladies and gents, the only thing I have left is how do we calculate percentiles? Even though it's not on this, let's talk, how do we calculate percentiles? Because what if I wanted to find out what the 20th, let's go, 80th percentile was? Well, to do it in StatCrunch, do it normally, we go how our sample size times 0.8 and find that position. That's the 80th percentile. But StatCrunch does it a lot quicker for us. So I want percentiles. And do that. This time I'm going to do stat calculator. And I want normal. All right. Well, that's not right. I apologize. I'm used to doing this in a calculator. So height. No, I guess it isn't here either. But I'm going to, okay, well, we'll do it the other way because I need height. And to do this, I need standard deviation. So I want the mean and the standard deviation. All right. We'll play along with stat. Now, I want stat, calculator, normal. I have to change the mean because the default, how most stuff works is the default set to 0 and 1. Well, this time my mean is 76.11538. I'm going to go ahead and put it in there with standard deviation of 54.971503. All right. The percentage is over here. So this will give me the X value. This will tell me the percentage, and the percentage is 80. So it'd be 0.80. Compute. So the 80th percentile would be at 222.38. That is precise. To do it by hand, doing this is different ways, and we're going to get a different answer. So how many pieces of data do I have? I have 26 times 0.8. So basically the 21st piece of data, which will be, come down here, which would be 190. This is using specific data versus, because this is telling me where 80% is, think like with the standard deviations. All right, this is the method you'll be using. You'll need the mean and the standard deviation. And again, we know how to calculate that quickly now, don't we? All right. So good luck. Let me stop share and stop recording. Good luck, all.